the last section in chapter 2 this morning. So we're still going to be talking about the graphs, but we're going to do 3 other graphs. Okay, and so the first 3 graphs, the ones that we've already done, we did those in quite a bit of detail because we drew them and then we also interpreted them. Okay, so for these next 3, we're going to go through, these are not quite as important, so we're going to go through them very quickly. Okay, just kind of hit the high points on the graphs. Okay, so this is the first one. It's called a Pareto chart. You don't have to draw the graph. I just have an example up here so you can kind of see it. I am going to put a little bit of information over here that you might want to jot down about the graph. Okay, and then we're going to look at an example. All right, so I mean, looking at the picture, you can see that it is a bar graph. Okay, on the x-axis, you're going to have your categories. Like in this example, you have states. And on the y-axis, you're going to have your frequency values. And so it's important to know that this particular type of graph is used for data that is not numbers. So like part of your data may be numerical, like on this particular example, we have the cost, which is kind of playing the role of our frequency. So that has a number sort of content, but it's not numerical all the way through because we're also dealing with states. Okay. So if your data is not numerical, you could do this Pareto chart. And then finally, the last thing that we want to note here is that when you do it, you want to start with your highest bar. So you're going to order your data from your highest bar down to your lowest. Okay. I'm going to write that down. So bars are ordered from the highest frequency to the lowest. And that ends up being the thing that probably students have the hardest time remembering, just to put them in order before they get started. All right, so let's go ahead then, and we're going to look at making sure that we can draw one of these charts. All right, so we've got an example. If you want to jot it down, that's fine. I can wait for you, or if you want to take a picture, however you want to do it, or if you don't want to do either, that's okay too. But we've got the locations, different places. Homes, small companies, large companies, agencies, and schools. And then we have the number of computers at each of those 5 locations. All right, so again, it has some numbers in it, all right, but because it is not completely numerical, it qualifies for this particular type of graph. All right, so let's go ahead and just see if we can get this thing drawn. All right, so I'm going to draw a graph there. Right, now I need to come up with a scale for the number parts. Remember, your frequencies are going to go up the y-axis. So the highest one is 240. So what might be something good to count by?
10.
Okay, I could do 10. That's kind of a lot, though, right?
Oh, yeah.
Yeah. What do you think?
50.
50, yeah, I think I'd probably do 50. Okay, I mean, you can do whatever, but you want enough that you got some detail, but you don't want so many that it takes you a long time to write them all out. All right, so I think 50 is probably a good place to go. All right, and I'm just gonna, I think, use the labels that they give me. They said number of computers, so I'm gonna jot that over here on the side. All right, and then my locations are gonna go across the bottom. So which location is gonna go first? Keeping in mind that we need to go highest to lowest, right? So we're gonna start with what?
250. I mean, 240.
240, so the home. So I'm gonna go ahead and just sort of draw a bar at 240. It should come right up against that y-axis. And then underneath that, I'm gonna write down the word homes. So I'll put the label right underneath the bar. Okay, what comes next?
Large company.
Large companies at 148. I'll draw another bar. Underneath that one, write large companies. Okay, then what?
Small company.
Small companies at 102. Then I guess schools at 47. And finally, government agencies at 33. All right, and then under that, I'm just going to use the same heading that they said, so location. All right, and we're done. All right, so anybody have a question on constructing that one? That's okay here. All right, anybody at home need to ask anything about that particular graph? Okay. All right, so let's move on. We'll look at the second type. All right, second type is a pie graph. You're hopefully familiar with that one. You see that from time to time in different places. So again, don't copy the picture. That's just to remind you of what a pie graph is, but let's put just a little bit of information over here. All right, so this graph is also used for data that's not numbers. Okay, just like the last one. All right, and then in order to draw the pie graph, you're going to need to do two calculations. You will need to calculate the percents. And you can see those on the labels over here, right? So the percents go on the labels. And you're also going to have to calculate the degree measurement, and that's going to tell you how big to draw each piece of the pie. All right, so let's look at an example on a pie graph. All right, so again, if you want to take a minute and jot this down, we've got snacks, potato chips, tortilla chips, pretzels, popcorn, snack nuts, and then we've got the pounds or the frequency for each one. I'll give you a minute if you want to write it, or if you want to take a picture of it if you're at home, or whatever you want to do with that. I'll give you just a minute to get it down. Okay, so what I'm going to do, remember we have to calculate percents and we have to calculate degrees. So I think I'm going to squeeze in a percent column right here. All right, and we'll work on that first. So remember that we did percents back when we did the frequency distribution in the first section. Remember that we said that a percent was calculated by taking the part and dividing by the whole, and then multiplying by 100, okay? So if I'm gonna do a percent for potato chips, then I'm gonna take the part, which is 11.2, and I'm gonna divide that part by the whole, which is 30, and then I'm gonna multiply by 100. All right, if you put that in your calculator, you should get 37, and then a bunch of threes. So we're just going to round that to 2 decimal places. So I'm going to do 37.33%. All right, everybody okay there? All right, and we're going to do the same thing for the other ones. All right, so if we move to the tortilla chips, then we're going to be putting in for the part, we'll put in that 8.2 on the top, divide it by 30, multiply by 100. All right, and I get 27.33. All right, you guys feel good? We can definitely do that. Okay. Anybody at home with a question on that? We can go ahead and do the other 3 real quick. Jump in if you have a question. Okay. All right, everybody's okay with that? Okay. All right, so then the other thing that we have to calculate, and I'll stick it over here, we have to calculate the degrees.
Quick question.
Yeah.
Every time, like, I know, like, sometimes, when I'm looking at percentages, like, I get confused, like, say, like, it's in a word problem. Do we always multiply by, multiply by 100 with percent?
Yeah, if it starts out as a decimal, then yes, multiply by 100, it makes it a percent.
Okay.
Okay. Okay, so to do the degrees, we do pretty much the same calculation. We're going to do part divided by the whole. But instead of multiplying by 100, the reason that we multiply by 100 is that there are 100 possible percents, okay? So if I'm talking about degrees in a circle, do you guys know how many degrees there are in a circle? All the way around the circle is how many degrees?
350.
360. Okay, so instead of multiplying by 100, we're going to multiply by 360 if we're converting to degrees, okay? So the part over the whole works the same way. We're going to take the 11.2 for the first one and divide by the 30. And then just instead of multiplying by 100, we'll multiply by 360. All right, and that's going to tell me what part of the circle that I want to allocate for that first class. Good, 134.4. Right. And then we're going to do the same thing for the next one. So we would come in on the next one and we would do 8.2 on the top here. Divide it by 30. And multiply by 360. Okay, so I get 98.4.
Yeah.
That's all good. Okay. All right, does everybody feel okay with that? Okay. All right, so I'm going to go ahead and do the other three. If you're at home and you have a question, jump in and ask. Okay. All right, so we're good?
So, I have a question.
Sure.
Was there ever come a time when we actually change the program?
Are you actually do what?
So, like, let's say we have to, like, turn like an actual paragraph, it's not like online thing, will we actually do that, or?
Like draw it, is that what you're saying?
Yeah.
Yeah, we're fixing draw it, and you'll have to do it, you'll have to do it. The question is, do you have to draw it? And yes. And in Connect Map, they give you like, they give you a circle and it has like the pieces and you can move the pieces to be the size that you need them to be. Okay. All right. We're gonna draw, go ahead and draw up here our circle. Okay. Now, like I said, when you're doing the homework, you can be very precise because as you move those lines to make pieces, it's going to tell you, you're at 30 degrees, you're at 31 degrees, you're at 32 degrees. We can't be that precise in class because I don't have anything to necessarily measure those angles with. So we're just going to estimate right now. Okay, but it'll be a lot more exact when you sit down and do your homework. Okay, so what I'm going to do is I'm going to go with one of these angles that I think I know what it looks like. Okay,
Probably 30.
30, you know what 30 looks like? Yeah. Okay, so here's what I would do too. I would say, all right, here is, okay, so here is what kind of angle right there? What angle did I just draw? Do you know what angle? A right angle. A right angle is how many degrees? 90. 90. So if I were to draw a 30-degree angle, I'm going to cut it into 3 pieces, and we'll try to get equal pieces. All right, so that would be 30, that would be 30, that would be 30?
Yeah.
Okay. All right, so on this first 30, I'm going to write down snack nuts, because that's what the 30 one is, right? And then I'm going to put the percent. Remember, the percent goes on the label. And then I'm going to get rid of this other stuff, which I kind of used to help me figure out how to draw it. All right, so we're gonna say that snack nuts is done. Okay. All right, look at popcorn. Popcorn is basically a 45-degree angle, right? So again, if I drew another 90, I'm gonna drop it straight down. So this is a 90 right here, right? Like this one is a 90?
Yeah.
Yeah. Okay, so a 45 would be what? How is 45 related to 90?
Half.
Okay, right. Okay, so I'm gonna take a line and sort of cut it in half. Okay. And then I'm gonna say this is popcorn. And then I'm gonna put the percent, so 12.67%. I'm gonna erase what I didn't need, which is this other part right here. All right, and now we're calling popcorn done. Okay. All right, so let's look at what's left. 134, 98, 51. All right, so let's try the 98 because I know what a 90 looks like. All right, let me see if I can draw a 90 here, maybe off of the top part here. All right, do we agree that that's basically a 90 right in here? Look like a 90? Okay, so 98, just a little bit more, right? So I think what I'm gonna do is just increase just a little bit, and then we'll call it 98, okay? Again, we're just estimating here just to kind of get a general picture of what this thing looks like. When you get to Connect Math, you're gonna have the ability to do it a little more accurately. All right, so name and percent. Okay. All right, so that leaves pretzels at 51 and potato chips at 134. All right, what do you think we should do here? Anybody, you guys have a thought on that one? Either of those two?
Or I guess do like acute angles now because it being small.
Okay, yeah, so the 51 should be like a small angle, right? And then the 134 should be pretty big. All right, so what I could do is say, you know, here's another 90. Cut it in half, that's a 45 up here. I need it to be just a little bit bigger. All right, so you could do kind of something like that to sort of estimate where you're at. All right, so the smaller one would be pretzels. 14.33%. And then the bigger one would be potato chips. 37.33.
Right?
Do it?
It look right. It look right.
Yeah, that looks right. Mhm. Probably this close. Yeah. Okay, any question? You good?
So when we doing that, we go by the degrees.
Go by the degrees. Go by the degrees to help you pick out, like measure the piece.
Okay.
And then use the percents on the labels. Okay, so this part is gonna be for the labels. And this part is gonna help you draw the pieces. All right, anybody at home with a question? You guys okay still? All right, so the last one we're gonna do is called a time series graph. All right, again, just an example picture up there. You don't have to draw that picture, just kind of looking at it. Time series, that's kind of what it sounds like. It has some unit of time. So you're gonna have, that it shows time. That might mean years or months or hours, something like that is going to be displayed on the x-axis of the graph. So you should have some reference to time if you're going to use this graph.
And these contain numbers, right?
Do what? These are, yeah, this is definitely going to be numbers all the way through. You can see that it's a type of line graph from the picture. All right, so on the x-axis, you're going to put the time. And on the y-axis, we're going to put the frequency, but it doesn't have to be frequency because you see here it's temperature. The time definitely has to go on the x-axis, and then whatever else you have would go on the y, sort of by default. I'm going to leave it as frequency, but it does, like I said, it doesn't always have to be the frequency. All right, so let's work on one of these. All right, so arson damage, we have the years and we have the damage in millions. All right, again, if you want to take just a minute and if it helps you to jot the data set down next to the graph, do that.
So for the homework, would it just be the graph I'm talking about today or fall? When we do the homework?
I'm sorry, I just,
Sorry, I thought for the homework, will it just be for the graph we talked about
Yes,
today?
yes. It's a relatively short, I think it's like 8 problems maybe,
Oh, okay.
pretty short.
And when our time run like the 14 days, it'll send us like an email to pay or.
It will just, I think when you try to log in, it'll tell you that you have to put your code in. So you need to, by then you want to go, I think most of them are going to expire like the first of next week.
The first.
Yeah, I think we get through the next test, so I'm thinking they're like set to expire like the second or the third. So
Okay.
probably we need to be planning on for next week.
Okay.
Okay. All right, so let's look at drawing this one. Remember that the time across the bottom, so I'm just gonna mark those years off with tick marks. So I have 2001, 2002, 2003, 2004, and 2005. All right, and I'll just stick the word years down here. That's a pretty generic label, but hopefully the other one's going to be a little bit better. All right, so if we look at our damage, which is what's going to need to go, remember the X has to have the time, and then whatever else you have is going to go on the Y. So we're looking at the damage. It goes from like 2.8 to basically like a 2 number up to 8.5, so maybe up to a 9. I'm probably just going to mark that off, okay? Instead of worrying about getting into the decimals, I'm probably just going to count by ones and go all the way up to 9. All right, and then I'm going to put damage. I'm going to do a little bit better than just damage. I'm going to say damage arson. All right, and then remember that it's a line graph, so we're basically just plotting points here. So above the 2001 at 2.8, okay, so maybe somewhere like right in here, I'm going to put a dot. All right, and then the next one is 2002, it's 3.3. Just reconnect as we go. That's just 3.4, so you probably don't see much difference between those two. Almost gonna look flat. 2004, we're up at 5. And then 2005 at 8.5. All right, and then we leave it like that. We don't pull the endpoints down because that would indicate that in the next year it went to 0, which we assumed didn't happen, or that in the previous year it was at 0, which also we assume is not the case. All right, so we just plot those 5 points and leave it like that.
So that's all we do for
That's all you do, yeah. All right, any questions on that one? Anybody at home with a question on that?